All right, someone's been doing their homework. Looks like you're really serious about Python this time. We've got a mountain of sources here.
Wow, yeah.
Everything from like beginner tutorials,
hmm
W3 schools, Codecademy,
Yeah, those are great.
to some deep dives on Wikipedia about Python's like history and design.
You really went deep.
Oh, and there's even a GitHub issue about a missing method. That's dedication.
That's awesome. It's fascinating to see such a range. It tells me you're not just interested in the what of Python, but the why and the how it's evolving.
Exactly. So for this deep dive, let's cut through the noise.
Okay.
What are the most important things you need to know about Python to actually use it effectively,
Yeah.
especially with that data science slant I'm seeing in some of these sources?
Yeah, well, first off, Python wasn't always the data science darling it is today.
Okay.
Guido van Rossum created it back in 1991
Wow.
as a successor to the ABC language.
Okay.
And that whole data science boom came, like, much later.
Hold on. You're telling me Python is older than I am.
Uh-huh. It might be.
And here I thought it was a new kid on the block.
It's definitely stood the test of time, though.
Yeah, it seems like it.
And speaking of time, one thing you'll appreciate as you get deeper into data science is how Python's design, how it prioritizes readability and simplicity.
Okay.
That one obvious way to do it, philosophy.
Yeah.
It really shines through when you're dealing with complex algorithms and data sets.
That makes sense.
Yeah.
The last thing you want is to be wrestling with like cryptic code
Yeah.
when you're trying to analyze terabytes of data.
Exactly, exactly. And that's where the beginner-friendly syntax comes in handy, right?
Okay.
You'll find that Python code often reads like plain English,
Oh, nice.
which makes it easier to learn and debug, especially when you're starting out.
That's a huge relief.
Yeah.
Honestly, some of those other languages, they look like hieroglyphics to me, but these tutorials mention dynamic typing.
Yeah.
Isn't that supposed to be like a double-edged sword?
It can be. Faster to write, but maybe more prone to errors.
That's a great point.
Yeah.
And it's something you'll need to be mindful of as you progress.
Okay.
The flexibility of dynamic typing, it can lead to runtime errors if you're not careful about how you're handling different data types.
I see.
But Python's also got your back with a robust set of error handling mechanisms.
Like that GitHub issue you shared.
Yeah.
Even experienced developers run into issues sometimes. It seems like the community is pretty quick to jump in and help resolve those problems.
For sure. Yeah,
That's definitely a good sign.
absolutely. Python's community is one of its greatest assets, I'd say.
Yeah.
You'll find tons of resources, forums, online communities. You can get help, share code, learn from others.
That's cool.
And that's especially valuable in the data science world, which is constantly evolving.
So it's not just about the language itself, it's about the whole ecosystem surrounding it.
Precisely. Python has this philosophy of batteries included, so a vast standard library with pre-built tools.
Oh, right. For all sorts of tasks. And for data science specifically, you've got an incredible array of third-party libraries like NumPy, Pandas, and SciPy.
Okay, those names keep popping up everywhere. What makes them so special for data science?
Well, NumPy gives you the ability to work with arrays and matrices efficiently, which is crucial for numerical computations.
Okay.
Pandas provides data structures like data frames that are perfect for organizing and manipulating tabular data.
So, like the kind you might find in a spreadsheet.
Exactly, like a spreadsheet.
Okay, got it.
So these are tools that are purpose-built for the kind of data wrangling that data scientists do day in and day out.
Got it. So they're like, what, super-powered spreadsheet?
Yeah, you can think of it that way.
Okay.
And then you have SciPy, which builds on top of NumPy. And it provides these advanced algorithms for scientific computing, statistics, optimization, really the heavy lifting of data science.
Starting to feel like Python really has everything you need to like dive into data science head first.
Yeah, it does.
But I've also seen some sources mention Python 2 versus Python 3. Is that something I need to worry about?
Not really. There was a major transition back in 2008 with Python 3, and it caused some headaches because it wasn't fully backwards compatible.
Oh, okay.
But thankfully, Python 2 reached end of life in 2020, so you're safe sticking with Python 3. You get the latest features and support.
Good to know. I don't want to get stuck with an outdated version.
Right.
Speaking of features, I've seen these references to things like the walrus operator and pattern matching.
Oh, yeah, those are cool.
It seems like Python is constantly evolving.
It is. That's one of the things that keeps Python fresh and relevant.
Okay.
There's always something new to learn. But even with all these changes, Python's core philosophy remains the same: readability, simplicity, and that batteries included approach.
That's reassuring. So it means once you learn the basics, you're not going to be completely lost when a new version comes out.
Right.
But before I get ahead of myself, let's talk about actually getting started with Python. What are the best ways to learn this beast?
Well, you've already got a great start with those online tutorials from W3 Schools and Codecademy.
Yeah.
They're perfect for beginners because they guide you through the fundamentals in a very hands-on way.
I'm also seeing mentions of integrated development environments,
IDEs.
or IDEs. Those sound a bit intimidating.
They're not as scary as they sound.
Yep.
Think of them as souped-up text editors designed specifically for coding.
Right.
They offer features like syntax highlighting, auto-completion, and debugging tools that can make your life a lot easier.
So kind of like training wheels for a programmer?
You could say that.
Okay. Any recommendations for someone just starting out?
Absolutely. Thonny is a great IDE for beginners.
Tell me, okay.
It's simple, lightweight, easy to use. For more advanced projects, you might want to consider PyCharm, which offers a ton of features for professional development.
And I've heard good things about VS Code, especially with the Python extension.
VS Code is a fantastic choice, especially if you're already familiar with it for other programming languages. It's very versatile and customizable, and the Python extension gives you all the tools you need for a smooth Python workflow.
Okay, so lots of options depending on your needs and experience level.
Yeah, for sure.
But before we go crazy with IDEs and libraries, shouldn't we understand how Python actually works under the hood?
You're right. Let's peek behind the curtain.
Yeah.
Most people use CPython, which is the reference implementation written in C.
Okay.
And here's the key thing. Python is an interpreted language.
Interpreted dot meaning.
It means that your code is executed line by the Python interpreter,
Okay.
rather than being compiled into machine code beforehand.
So it's like having a translator running alongside your code.
That's a great analogy,
Okay.
telling the computer what to do step by step.
Got it.
And this has implications for both speed and portability.
Okay. I'm intrigued. Tell me more.
Well, interpreted languages tend to be slower than compiled languages because of that extra layer of translation. But they also tend to be more portable because you can run them on different operating systems without having to recompile the code.
Ah, so it's a trade-off. Speed versus portability.
Exactly. And that's where things like bytecode come in.
Okay, bytecode. That sounds familiar, but I need a refresher.
So bytecode is an intermediate form that your Python code is compiled into. It's not pure machine code, but it's closer to it.
Okay.
And it's what the Python virtual machine actually executes.
So it's like a compromise. A way to make Python code more portable without sacrificing too much speed.
You got it. And it's also worth noting that there are alternative implementations of Python besides CPython.
Like what?
Well, there's PyPy, which uses a technique called just-in-time compilation to boost performance. It can make your Python code run significantly faster, especially for certain types of applications.
So you've got options depending on your priorities.
Exactly.
But even though Python has been around for a while, it's clear that it's not standing still.
For sure.
What about some of those deeper concepts and tools that serious Python developers use,
Right.
like linting and debugging?
Those are definitely essential skills, and Python's got you covered. Linting tools analyze your code for potential errors and style inconsistencies, which can save you a lot of headaches down the road.
That sounds like a lifesaver.
Yeah.
Especially for someone like me who's just starting out, prone to making mistakes.
We all make mistakes.
Yeah.
And debugging tools let you step through your code line by line, inspecting variables and figuring out where things went wrong.
So it's like having a microscope for your code,
Exactly.
letting you zoom in and see what's happening at each step.
Exactly. And Python's debugging tools are pretty powerful.
Okay.
But debugging is just one piece of the puzzle. You also need to think about managing different Python versions and dependencies, especially if you're working on multiple projects.
That's where virtual environments come in, right?
Yeah.
I've seen those mentioned in a few of these tutorials.
They're essential. Virtual environments allow you to create isolated spaces for your projects,
Okay.
each with its own set of dependencies.
So you don't end up with conflicts between different versions of libraries and stuff.
Precisely. And tools like Conda can make managing environments even easier. But once you've got your environment set up, you need to make sure your code actually works as expected.
Which is where testing comes in.
Got it.
Right.
Testing is crucial for ensuring code quality, and Python has some great frameworks like UnitTest and PyTest that let you write automated tests for your code.
Automated tests. So you don't have to manually check everything every time you make a change.
That's the idea. It saves you a ton of time and helps catch errors early on. And speaking of catching errors, we haven't even touched on exception handling, which is how Python deals with unexpected events that could crash your program.
Okay, exception handling.
Yeah.
I think I need a whole deep dive on just that. But for now, I'm starting to see why Python has become so popular, especially in data science. It seems like it has the right blend of simplicity, power, and flexibility to tackle just about any data-related challenge.
It does. And that's not even mentioning the sheer breadth of the Python ecosystem.
Oh, wow.
There are literally thousands of third-party libraries out there for everything from machine learning and web development to game design and scientific computing.
Wow. It really does seem like Python can do just about anything. But before we go off on too many tangents,
Right.
let's focus on those data science libraries that you mentioned earlier.
Yeah, okay.
Those seem to be at the heart of why you're diving into Python in the first place.
Absolutely. Let's explore what makes these libraries so powerful and how they can help you unlock the insights hidden within your data. All right, let's unpack these data science powerhouses. You've got NumPy, Pandas, and SciPy, each playing a crucial role. If you imagine your data as a messy room, full of potential but hard to navigate,
Okay.
these libraries are your cleaning crew, organizer, and interior designer all rolled into one.
Okay, I like that analogy. So NumPy is the heavy lifter, right?
Yeah.
Dealing with all those numbers and calculations,
Exactly. It's all about efficiency. NumPy provides these things called arrays.
which are like supercharged lists designed specifically for numerical computations. Think of it like this.
Okay.
If you're doing a simple calculation on a few numbers, a regular Python list might be fine.
Right.
But if you're crunching millions of data points, those tiny speed differences,
Oh, yeah.
they add up fast.
Yeah.
NumPy's arrays are optimized for those large-scale operations, making your code run much faster.
So it's like the difference between walking to the store and taking a high-speed train.
That's a great way to put it. And NumPy doesn't just make things faster. It also provides a ton of built-in functions for mathematical operations,
Yeah.
linear algebra, random number generation, and more. It's the foundation upon which a lot of other data science libraries are built.
Okay, so NumPy lays the groundwork. What about Pandas? What's its superpower?
Pandas is all about organization and manipulation. It introduces these things called data frames, which you could think of like powerful spreadsheets within your Python code.
Oh, okay. They're perfect for storing and working with tabular data, data that's organized into rows and columns, like what you'd find in a CSV file or a database table.
Ah, that makes sense. A lot of real-world data comes in that format,
Yeah.
like sales records, experimental results, or sensor readings. So
Yeah.
Pandas makes it easy to, like, load, clean, and transform that kind of data.
Exactly. Pandas gives you a ton of tools for slicing and dicing your data, filtering rows based on specific criteria, handling missing values, merging data sets, and much more. It's like having a Swiss Army knife for data manipulation.
Sounds incredibly useful. And these data frames seem pretty flexible. I bet you can do some interesting visualizations with them, too.
You're on the right track. While Pandas itself isn't focused on visualization,
Okay.
it works seamlessly with libraries like Matplotlib and Seaborn
Oh, right.
to create informative charts and graphs from your data, so you can go from raw data to insightful visualizations all within the Python ecosystem.
That's really powerful. So we've got NumPy for the raw number crunching, Pandas for organizing and manipulating data.
Yeah.
Where does SciPy fit into all this?
SciPy builds on top of NumPy and provides a collection of algorithms and functions for scientific and technical computing. Think of it as the library that lets you apply advanced mathematical and statistical techniques to your data.
Okay, give me some concrete examples. What kind of stuff can SciPy do that NumPy and Pandas can't?
Well, SciPy has modules for things like optimization, linear algebra, integration, interpolation, signal processing, image processing, and much more. It's the library you'd turn to when you need to do things like fit a curve to your data, perform a Fourier transform, or solve a system of differential equations.
Well, that's getting pretty heavy into the math and science.
It is. But the beauty of SciPy is that it abstracts away a lot of the complexity, providing easy-to-use functions that let you apply these powerful techniques without having to write all the low-level code yourself.
That's the batteries included, philosophy in action.
There you go.
So if I'm understanding this right, NumPy provides the foundation.
Yeah.
Pandas gives you the tools to organize and clean your data. And then SciPy lets you apply more advanced algorithms and analysis on top of that.
That's a great summary. And these three libraries work together seamlessly, forming a powerful trio for tackling just about any data science task you can throw at them.
It's really impressive how well these libraries complement each other.
Yeah.
But I'm curious, What are some real-world examples of how these libraries being used in data science?
Yeah.
Like, what kind of problems are they solving?
Oh, the possibilities are endless. Let's take a look at some of the sources you provided. Maybe we can find some relevant examples there.
Sounds good. I've got this article here about using machine learning to predict customer churn.
Okay.
It mentions something about using scikit-learn, which
Right.
I know is a popular machine learning library for Python.
Scikit-learn is another fantastic library, and it leverages those foundational libraries we've been talking about, NumPy, Pandas, and SciPy. In the context of churn prediction,
Okay.
you might use Pandas to load and clean your customer data. Then use scikit-learn to train a machine learning model on that data to predict which customers are most likely to churn.
So you're using historical data to train a model that can then make predictions about future behavior.
Yeah,
That's pretty cool.
it is. And scikit-learn provides a wide range of machine learning algorithms, from simple linear regressions to more complex models like support vector machines and decision trees.
And it sounds like these libraries can be used for all sorts of machine learning applications, not just churn prediction.
Absolutely. Scikit-learn is used in fields like image recognition, natural language processing, fraud detection, really anywhere you need to extract insights or make predictions from data.
That's really amazing. It's starting to feel like there's no limit to what you can do with Python and these data science libraries. But I'm also seeing some sources here about data visualization. How does that fit into the picture?
Data visualization is an essential part of data science. It's not enough to just crunch the numbers. You need to be able to communicate your findings in a clear and compelling way. And that's where libraries like Matplotlib and Seaborn come in.
I've heard of Matplotlib. It's like the granddaddy of Python visualization libraries, right?
It is. Matplotlib gives you a lot of control over creating static, interactive, and animated visualizations in Python. You can create all sorts of charts and graphs, from simple line plots and scatter plots to more complex 3D visualizations.
And Seaborn builds on top of Matplotlib. What's its special sauce?
Seaborn is designed to create statistically informed visualizations
Okay.
that are both visually appealing and informative.
Okay.
It provides a higher-level interface than Matplotlib, making it easier to create common types of statistical plots like heat maps, violin plots, and pair plots.
So it's like Matplotlib for people who want to create beautiful and insightful visualizations without getting bogged down in the nitty-gritty details.
Exactly. And both of these libraries work seamlessly with NumPy and Pandas, allowing you to easily visualize the data you've loaded and manipulated with those libraries.
It's really starting to feel like Python has a whole ecosystem dedicated to making data science accessible and powerful. But one thing that I'm still a bit fuzzy on is the whole concept of environments in Python. You mentioned virtual environments in Conda earlier. Why are they so important?
Environments are crucial for managing dependencies, especially when you're working on multiple projects or collaborating with others. Let's say you're working on a project that uses a specific version of a library,
Right.
but then you start working on a different project that requires a different version of the same library. Things can get messy quickly.
So it's like having separate workspaces for each project so they don't interfere with each other.
That's the idea. Virtual environments allow you to create isolated sandboxes for your projects, each with its own set of dependencies.
Okay, starting to see the value in that. And what about Conda? How does that fit into the picture?
Conda is a package manager and environment management system. It's not strictly a Python tool,
Okay.
but it's very popular among Python data scientists.
So in addition to managing Python packages, it can handle dependencies for other languages too.
Exactly. And that can be really helpful when you're working with data science tools that rely on libraries written in other languages like C or Fortran. Conda can make sure you have all the necessary dependencies installed and working together correctly.
Sounds incredibly useful. So virtual environments and Conda are like the unsung heroes of the Python ecosystem, keeping everything organized and running smoothly behind the scenes.
They are. And they can save you a lot of headaches in the long run, especially as you start working on more complex projects.
Okay, I'm feeling a lot more confident about tackling those environments now. But before we move on, is there anything else we should cover about Python's core features that might be relevant to data science? I know we talked about the differences between ease and ease earlier, but are there any other quirks or gotchas I should be aware of?
That's a great question. One thing that trips up a lot of people, especially those coming from other programming languages, is Python's focus on indentation.
Indentation, you mean like how many spaces I put at the beginning of a line of code?
Exactly. In Python, indentation is not just about making your code look pretty.
Right.
It's actually part of the language's syntax.
Wait, really? So how I indent my code
Mm,
actually affects how the code runs?
absolutely. In many other languages, curly braces are used to define blocks of code.
Right.
But in Python, indentation is used for that purpose. So
Interesting.
if you indent your code incorrectly, you can get syntax errors or unexpected behavior.
Okay, that's something I'll have to pay close attention to. I'm used to indentation being more of a style choice,
Right.
not a hard and fast rule.
It's definitely something that takes some getting used to, but once you understand how indentation works in Python, it actually makes your code more readable and consistent.
That's good to hear. It seems like a lot of Python's design choices are centered around readability and simplicity, which makes a lot of sense, especially when you're dealing with the complexities of data science.
Exactly. And there are other features of Python that are particularly relevant to data science, like list comprehensions and generator expressions, which can make your code more concise and efficient when working with data. But those are topics for another deep dive.
All right, I'll add those to my list of things to explore. But for now, I think we've covered a lot of ground. We've talked about the power of NumPy, Pandas, and SciPy, the importance of environments, and even some of Python's quirks, like indentation. I'm feeling a lot more confident about diving into the world of data science with Python.
That's great to hear. And remember, one of the best things about the Python community is its welcoming and supportive nature. Don't be afraid to ask questions, share your code, and learn from others. There are tons of resources out there, from online forums to meetups and conferences.
That's really reassuring to know. It's nice to feel like you're not alone on this journey.
Right.
So we've talked about the libraries, the environments, even some of Python's, quirks.
Right.
But what about the actual process of, writing and running Python code?
Yeah.
What are the tools and workflows that data scientists use to get things done?
That's where things get really interesting. And it ties back to those IDEs we mentioned earlier, integrated development environments. Remember, they're like souped up text editors designed specifically for coding, and they can make your life a lot easier, especially as you start working on more complex projects.
Right, we talked about Thonny for beginners and PyCharm for more advanced users,
Mm-hmm.
but I'm still a bit curious about VS Code. It
Yeah.
seems like it's incredibly popular, not just for Python, but for a whole range of programming languages. What's the secret sauce that makes VS Code so versatile?
VS Code's strength lies in its extensibility and its vibrant community. At its core, it's a very lightweight and customizable editor. But the real magic happens when you start adding extensions.
Extensions. So it's like adding plugins to a web browser to give it new capabilities.
Exactly. And there's an extension for just about everything you can imagine. Language support, debugging tools, themes, integrations with other services, you name it. And for Python specifically, the Python extension is a must-have.
Oh, cool.
It provides features like IntelliSense, linting, debugging, testing support, and even integration with virtual environments and Conda.
So it's like turning VS Code into a full-fledged Python IDE with just a few clicks.
Pretty much. And because VS Code is open source and has such a large community, there's a constant stream of new extensions and updates being developed.
That's really impressive. It sounds like VS Code is a great choice for anyone who wants a flexible and customizable environment that can grow with them as they learn and their needs evolve.
It is, but IDEs are just one part of the equation. You also need to think about how you're going to manage your code, collaborate with others, and share your work.
That's where version control comes in, right? I've heard that term thrown around, but I'm not entirely sure what it means.
Version control is a system that allows you to track changes to your code over time. Think of it like having a time machine for your code. You can go back to any previous version, see what changes were made, and even revert back to an earlier state if you need to.
So it's like having an undo button that goes back indefinitely.
That's a good way to think about it, but it's much more powerful than that. Version control allows you to work on different branches of your code, experiment with new features without breaking the main code base, and merge changes from multiple collaborators seamlessly.
That sounds incredibly useful, especially when you're working on larger projects or with a team. What are some popular version control systems that Python developers use?
The most popular one by far is Git. It's a distributed version control system,
Okay.
which means that everyone working on a project has a complete copy of the code's history.
So it's like having a backup of the entire project on everyone's computer.
Exactly. And that makes it very robust and resilient. And then there are services built on top of Git like GitHub, GitLab, and Bitbucket, which provide online platforms for hosting your code, collaborating with others, and managing your projects.
I've definitely heard of GitHub. It seems like it's the go-to place for open source projects
It is, yeah.
and sharing code.
Yeah.
It's a fantastic resource for learning and exploring Python code. You can find countless open source projects, libraries, and even entire data science workflows that you can learn from and adapt for your own needs.
That's a great point.
That's really inspiring. It's like having access to a vast library of code and knowledge that you can draw upon. But with so many tools, libraries, and resources available, it can feel a bit overwhelming at times. What advice would you give to someone who's just starting out with Python and data science? Where should they focus their energy?
That's a great question. The most important thing is to start with a solid foundation in Python's core concepts.
Good.
Data types, control flow, functions, and object-oriented programming.
Right, we talked about those earlier in this
Yes.
deep dive.
Exactly. Those are the building blocks for everything else.
Once you have a good grasp of the fundamentals, you can start exploring the data science libraries, NumPy, Pandas, and SciPy. And don't be afraid to experiment, make mistakes, and learn from them.
Exactly. And then there are communities like Stack Overflow and the Python subreddit where you can ask questions and get help from experienced developers.
It's amazing how supportive and welcoming the Python community is. It definitely makes the learning process a lot less daunting. But even with all these resources, is there anything else that someone who's serious about data science should be doing to stay ahead of the curve?
One of the best ways to learn and grow as a data scientist is to work on real-world projects. Find a data set that interests you,
Yeah.
come up with a question you want to answer, and then use Python and its data science libraries to explore that data and see what insights you can uncover.
That sounds like a great way to put all of these tools and techniques into practice.
It is. And don't be afraid to share your work with others. Create a GitHub repository, write a blog post, or present your findings at a local meetup. Sharing your work not only helps you learn and grow, but it also contributes to the vibrant and collaborative spirit of the Python data science community.
That's really inspiring advice. So as we wrap up this deep dive, what are the key takeaways you hope listeners will walk away with?
Python is an incredibly powerful and versatile language, especially for data science. It has a rich ecosystem of libraries, tools, and resources that can help you tackle just about any data-related challenge. But beyond the technical aspects, what really makes Python special is its community, a welcoming and supportive group of people who are passionate about sharing knowledge and helping others succeed.
I couldn't agree more. Python is more than just a programming language. It's a gateway to a world of possibilities where you can use data to answer questions, solve problems, and make a real impact.
Exactly. So if you're curious about data science, or if you're looking for a powerful and flexible language to add to your toolkit, I highly encourage you to give Python a try. You might be surprised by what you can accomplish.
All right, and there you have it, another deep dive complete. Until next time, keep exploring, keep coding, and keep that Python spirit alive.